Hello everyone, I want to welcome you back to this lecture series. Today we're going to be talking about the second part of the periodic table, and I titled the lecture Periodic Table 2. Let's take it away. At the end of this lecture, we should be able to classify elements based on their groups or their family, which is the vertical column, which is also determined by their valence electrons, and then as metals, as non-metals, and then metalloids. Those are the things we're going to be getting at the end of this lecture. Let's take it away from there. So element classification. Elements in the periodic table are classified using a lot of criteria. In this place, we're going to be using these criteria. We'll classify them as a representative or main group element. I remember that I told you what this is earlier, that the main groups are the group 1. We talked about this earlier. Group 1A, we're going to use American system. Group 2A, 3A, then group 4A, group 5A, group 6A, and then, okay, group 6A, 7A before 8, 11, before, group 7A, and then group 8A. So those are the main group elements. We'll classify them as transition elements, in the inner transition element as well. And then we'll take a look at the broader classification that classifies them as metals and non-metals and then metalloids. Alright, heading to the next slide. So let's look at those classifications. So classification of element. Classifying element as representative or main group element. Like I said earlier, those represent a main group element. Now, this is further classified or categorized into the following. Elements group 1A are called the alkali metals. Group 2A are called the alkali earth metals. Group 3 are the boron family, which is group 3A. Group 4A is the carbonoid family, which is the carbon family. Group 5 is the nitrogens, which is like the nitrogen family. Group 6 are the chalcogens, Group 7 are the halogens, and Group 8 are the noble gases. Then as transition element, these are the ones that are found in between Group 2 and Group 3A. And we said earlier that the oxidation state varies. That's why we call them transition. And then those ones that are inner transition are those ones that are found at the bottom of the periodic table, that are conveniently placed there at the bottom of the periodic table. Let's take a look at what this classification looks like. Again, this is the vertical column that we call the groups. So group 1A here is called alkali metals. I can use my highlighted alkali metals. Group 2A are the alkali metals, alkali metals. Then group 3A are the boron family. Group 4A, we have the carbonoid family. Group 5A are the nitrogens. Group 6A are the chalcogens. Group 7A are the halogens, and group 8 are the noble gases. Then we have this boundary here. Remember, these are the transition metals. Are the blue part of these are the transition metals. These are the transition metals, which is basically from group 3B to this group 2B. That the transition metals here. And then under this periodic table, we have the lactonite and the actinide, which are the inner transition. So the inner transition metals, this is the inner transition, of course, the inner transition metals. The inner transition metals have the first row. The first row are the lactonite family. We call them the lactonites. The lactonites. And then the actinites here. Whereas, of course, I have the key here. The representative are in this color. And then the light blue here, this is like purple color are for the representative. The light blue here is the transition, and the inner transition is the dark blue, or much more thicker blue there. So those are going to help you to understand. And again, using your full periodic table, you can always see the examples of each. So I'm going to fill it out, maybe a few of these. Here, lithium is an example. Lithium, sodium here for the alkali metals. Here you can put beryllium here. Beryllium and magnesium, but you know, there's no space there to put it. And I have the group 3 here, of course. This is boron, the boron family, aluminum. And then group 4 is carbon here, carbon and silicon, the first two there. Then group 5 is nitrogen and phosphorus are the first two. Group 7, there you have fluorine and chlorine. Group 6A, there you have group 7A. Group 7A, you have oh, there's a mistake. Oh, wait, I'm supposed to put group 6A is you have oxygen and sulfur. Here you have fluorine, group 7A, and chlorine. And here you have helium is number one. Here, of course, helium, neon, and argon. And then we'll look at the periodic table in the next page. You can easily populate this with a common examples of what we have there in the periodic table. So because I can ask the question, give me an example of one of those. So here this is scandium, and here this is titanium. You can have that example. Here this is lactonite. Of course, this is actinide series. That's what we call it. This is the lactonite family. This is the actinide family. And there are other examples here you can always put in there. So these are the common examples of each of those classes. And it will be important for you to try to at least be able to know an example of this class of elements, of each class of elements, both in the main group element, the transitional element, and the inner transition element. We'll now look at the full periodic table here, which I also made this periodic table. So these are common examples there. So you can always use these to, fill those up. Of course, the blue shade here means the metals. The green boundary is metalloid, and the yellow is the non-metals. And these are, remember these guys and these guys have been put into this. We're at this last part of the periodic table, which are the inner transition. Alright, so let's go to the next classification, which is classifying based on metals, non-metals, and then metalloids. So, yeah. So elements can be classified on the basis of metals and non-metals, like I said earlier. So metals are found at the left 2/3 of the periodic table. There are more metals than the non-metals in the periodic table. Of course, they have properties. What are the properties? They have high thermal conductivity and high electrical conductivities. They are very highly ductile. Ductile means that they can be drawn into wires. They are malleable. They can be beaten into shapes, and they have metallic loss. That means they can shine. They shine very well. They are so shiny, like your gold jewelry is very shiny. Again, like I said, ductility means they can be drawn into wires. They can be drawn into wires. Drawn. Let me write that. Into wire. The important characteristics of metals. And then they are shiny. Here, this means they are shiny. Here means they can be beaten into shapes. Beaten into shape. Now, elements that are found, non-metals are elements that are found in the right 1/3 of the periodic table, which are the non-metals. Now, their properties are just directly opposite of those of the metals, and they are mainly brittle. They can easily be broken down. They are brittle, powdery, solid, or liquid and gases. Right? Again, they have low melting and boiling point when you compare them to those of the metals, and they have low thermal and electrical conductivity as well. So they just share properties that is directly opposite of those of the periodic table. So like I said, there are more metals 2/3 to the non-metals, which is 1/3 in the periodic table, as we're going to be seeing in this again. Again, if you look at this, the key is here. The blue here is the metals, which is located to 1/3 side of periodic table. The non-metals are located to the right here. And then the boundary here are the metalloids as well. And again, I used the common American grouping to show you this thing, which is in Roman numeral. So the periodic, it should be able to give me an example of each of these guys as a metal and non-metal. If I say give me an example of metal, you know how to look at that. If I say give me an example of a non-metal, you know how to. If I say give me an example of a metalloid, you know how to look at that again in the periodic table. So metalloids, let's talk about metalloids. Metalloids are one of the most important elements that have revolutionized the world we live in currently today. So elements that have formed the diagonal separation, of course, they form the diagonal separation in the periodic table, diagonal separation zone between the metals and the non-metals in the period. They basically divide the metals and the non-metals. They have properties between those of the metals and the non-metals, and often exhibit some characteristic properties of each group. Common examples are here the silicon, which is named after the Silicon Valley, where silicon itself has revolutionized our electronic industry. And today, anybody who has the best chips will definitely be one of the richest man in the world, because richest person in the world, because it will keep making our life better and making the way we work better every day with the use of computers, the phones, all electronic devices all have chips in them. So those chips are usually made with this, with a metalloid, either silicon or germanium. Germanium is also gaining a lot of steam recently. I think recently they said germanium is the best chip making metalloid there, and the boron, arsenic are all examples. There are other ones there too, like antimony, SB. Antimony is a metalloid as well. We have Te, which is tellurium, is also a metalloid. We have the ones there. At, which is astatine. Astatine is a metalloid. And even tennessine is also a metalloid. All these are all metalloid that can be found the periodic table. Now, a city in California is named Silicon Valley, of course, which should be the birthplace of where chips was discovered, right? So the city itself was basically named after Silicon Valley, here in, just close to Washington, here in California. All right, let's go to the next reflection questions here. It says, use the periodic table. Here, use the periodic table to determine the following for Sr, Cl, Se, Xe, Mo, Ge, and Am. This is strontium, chlorine, selenium, xenon, molybdenum, germanium, and americium. So we're going to classify them based on representative, transition, inner transition, or noble gas, and then as metals, non-metals, or metalloids. So let's start that. So the first thing we're going to do is to classify them based on the representative group. So the representative, we want to say A. Let's see. The representative groups are group 1 to group 8, excluding the transition and the inner transition. So those ones let's try to locate a few of them. Strontium. What about, let's start from strontium. Strontium is in group 2, which is a transition. Strontium, what else? Chlorine, of course, chlorine is here. Chlorine is that. What else? Selenium, yes, selenium is here. Is in group 6. So selenium is a main group element. Is a representative or main group element. And then which other one do we have there? We have xenon is a noble gas. We're going to put it there. Xenon is a noble gas, which is also a representative element. Xenon, molybdenum. Okay, xenon. So we're not done. So other representative, other ones we're going to do here. So let's see germanium. Where is, so germanium is here, is in group 4. Yes, germanium. No molybdenum. Molybdenum is not a representative element. Molybdenum is here, so we're not putting it, and we're not putting americium. Americium itself is down here, is an inner transition. So these 4, 1, 2, 3, 4, 5 are all representative elements. So these are all representative elements. Okay, element. Let me write that well. Then B. So we've knocked this one out. What about the transition? Let's see, which one is the transition element? So from there, molybdenum to me is the only transition element I see here. So that's transition. And then C, that's the only transition that I have there, which is this. Americium is an inner transition. Let's look at it. Americium here is an inner transition element. So Am is an inner transition element. Then what else? Okay, let's see. Noble gas. The only noble gas we have here is what? Did I even share it? Xenon is a noble gas. Xenon is a noble gas. So which other one do we have here? E. Let's see if I have more. What about the metals? Let's classify them as metals. Which are the metals here? So the metals here will be, let me use a different color. So the metals will be, strontium is a metal. Which other one? Molybdenum is a metal. Americium is a metal. I know those three are all metals. The rest are non-metals. So let's write them there. Yeah, so these are all non-metals. So those are the three that are metals. All right, so we'll write them out. So the metals will be strontium, molybdenum. Remember, this blue shade here are the metals, and americium are all metals. They're all metals. Okay. EF. Okay, what about the non-metals here? Well, let me make that. Okay, then F. What about the non-metals? Let's see. The non-metals will be, yes, let's use this. The non-metals will be chlorine is a non-metal because we have it here to the right. Xenon is a non-metal. Selenium is a non-metal. And which, yes, those are all non-metals. So we're going to put them down. So chlorine, selenium, xenon are all non-metals. And finally, we can do one more. EFG, let's put G here. What about a metalloid? What's the only metalloid we have there? The only metalloid we have there is going to be germanium. That's the only metalloid we have there. Germanium is the only metalloid we have there. So germanium is a metalloid. That's the only metalloid we have there. So you can actually classify elements based on this common grouping in the periodic table. And what this does is that it helps you to begin to understand the structure of the periodic table and how actually to read and interpret it. Let's go to the next question. It says europium is an example of what element? Europium, if you go to your periodic table and look, europium is here. Yes, if you look at that, europium is number 63, EU, and so it's an example. Since it's down there, it is what? An example of what? An inner transition element. So it is an example of an inner transition element. Now we go to the next question. It says, which of the following is a transition metal? Is a transition metal? That's a keyword. Of course, the transition metals are those guys that are located within this block, of course. They are the transition metals. There are the extended ones, which we're going to talk about in much more different time. So here, if you look at it well, see which of the following is an example of a transition metal, and that gives us gold. Gold is AU. See it here. Gold is AU. So potassium is group 1. So we know it's not that. And then we know rubidium. We know plutonium is not it. We know these ones are not it. So it is gold that we find there. Gold, of course, is AU. All right. The next one there, we're going to be, I think that will be the last problem here. We're going to talk about which of the following is a metalloid. Of course, when you look at this diagonal separation, is when you see your metalloid. So which of the following is a metalloid? Potassium is not. Gallium is not. Selenium is not. It has to be all germanium. And germanium, of course, is number 32 in the periodic table. The guy, germanium is what? A metalloid, and that is the answer to that. All right. I think at this point, we've come to the end of this lecture. Thank you for listening, and bye at this time.